Oops, there was a problem about the audio. I restart. Sorry. Good morning and thank you to be present on our webinar. First of all, I introduce me. I'm Davide Perina, Product Manager for Thermal Management, Air Conditioner, Heat Exchanger and Ventilation. Today we speak about the e-mobility and how the conditioning contribute on the supply electrical network in order to charge the hybrid electrical cars. Before to start, here you can see a link. It is available on section question and answer. Please save the link at the end of the webinar. Click on the link to open the form and fill in the form. It is way you will receive the slide of the presentation webinar. In case you have the question, please write on the question and answer section, and I answer you at the end of the webinar. The first electrical car born in the 1800, it had a short boom until the beginning of the 19,000. Then the design and the production shifted to the combustion technology. Its costs were drastically become lower than the electrical car. It is due to the invention of the assembly line. Moreover, it had advantages about higher autonomy concurrently to reduction of the noise and pushed to the invention of the starter motor. It was a total hegemony until the oil crisis from the years 70s, where it made resume a need of the alternative technology. For next year, there were many projects and prototypes with poor success, until the last year where the mobility are talking and increasing the market share. The automotive industry and energy supplier have been oriented to electrical mobility. It is due to the greater attention to the consumption of the fossil fuel. It is one of the main factors for the pollution on the urban areas, because fine powders, hydrocarbons, and so on are produced, in addition to increase the CO2 level on the air and increase the greenhouse effect. To reduce the pollution emission, the local administration are making more frequently the circulation restriction of the cars that don't comply the precise circulation parameter. The introduction of the green cars, it is basic to reach the target of the World Conference on the Paris in the 2015. Theoretically, the target was at least 600 million of the electrical cars in the 2040. The forecasts don't reach this value, but they are very considerable, as we can show in these two graphics. This is helped by two main factors. The first is the growing of the market about battery. For example, European Community was to finance with 160 billion euros the market of the accumulation network for next 30 years, and the radical collapse of the price of the battery. It was $1,000 for kilowatts, now $200 kilowatts, with a forecast of $40 for kilowatts in the 2040. The second factor is the incentives of the single state. For example, the Germany has increased from 3 to 6,000 euro the maximum contribution for the purchase of the new car with zero emission, but with up to price below 40,000 euro of the cars, in addition to 3,000 euro of the bonus offered by the automotive houses. France has allocated a bonus in order to purchase an electrical car of the 7,000 euro and 2,000 euro for purchasing of the plug-in car. In addition, up to 5,000 euro in case the old car is scrapped. Now we see the technical features, beginning to understand which are the types of the car with the low environmental impact. Fuel cell electrical vehicle. The electrical energy is produced by a chemical process between the hydrogen and oxygen. It is stored by high voltage battery and an electrical engine used it. Mild hybrid electrical vehicle. The car is composed of a combustion engine and an electrical one, which operate only on integration on the acceleration phases. Full hybrid electrical vehicle, similar to previous models, but the electrical engine is more powerful, that allows to travel for few kilometers with 100% electrical modality. Plug-in hybrid electrical, it is a full hybrid with more electrical power, and it's possible to charge the car by the cable. At the end, the battery electrical car with only electrical engine. The market has consolidated on the last two types of the cars because the fuel cell electrical cars have high production cost than the hybrid electrical cars, and for poor or no presence of the distribution on the territory. The solution mild and full hybrid, in course of the time, they have been put on the second floor because the electrical support is limited. Now we see the future on the network begin to understand the charging classes. Slow charging up to about 8 kilowatt, domestic charge in alternative current in the private sector, charging time 6-8 hours. Quick charging from about 8 kilowatt up to 22 kilowatt. Charge in the public or private sector in alternative current. Charging time is a few hours. Fast charging more than 22 kilowatt. Charge for the short stops. Charging time up to also only 10-20 minutes. Charging mode in direct current. In the first period, when there were very few electrical cars, the most installation referred to reduce power and charging mode are slow and quicker modes. In the last year, the charging station with the grid power are increasing, with up to 40-50 kilowatt and some solution up to some 100 reaching the 350 kilowatt. Which are the charging modes? Mode 1, domestic charge, uses normally socket and plug. With this type of the charging mode, the vehicle is directly connected to the socket and is suitable bike or scooter. Mode 2, similar to previous type, but on the cable is present a control device. The sockets are domestic or industry type. After 3 and 4 modes with more interesting. Mode 3, public charge for big plant or public charge station. Safety system are needed. Mode 4, direct charging with the direct current. Uses a charger that it is out of the car. The AC power is converted into DC power in the charging column. It's useful to mark two factors that will be important for the growing of the mobility. Integration with the smart grid and use of the energy production by renewable sources, as wind or sun. The network will be called smart city. From charging station to the supply device, everything needs to be monitored in order to make more efficiency the network and start the activity in short time in case of the failures are present, or even to make activity for predictive maintenance. Moreover, on the charging station, the energy storage is useful for the low voltage solution without the use of the conversion cabinet, and to help the supply of the several charging columns with the presence of the more vehicles in charging. Electrochemical energy storage is the typical one by batteries. The energy storage is the junction ring between the wind solar plant and the charging station. It is useful to understand how the network and the infrastructures are built upstream to the charging station. Then depends how it supplies the electrical car. So if it is an alternative current or indirect current charging. Here we show three examples. First two in AC and the last in DC version. Of course, the structure can be an hybrid solution with both charging stations, AC and DC types in the same place, in order to satisfy both requests. On the three examples, we can see upstream of the network, the transformer, inverter, and the energy storage device in combination or standalone. We have seen that the request of the power is increasing, and so also the quantity of device inside the charging station is increasing. But it needs a small dimension. It is necessary to find solution that combines high performance and optimized layout. The optimization of the space creates more density of the component, getting worse the working condition inside the system. It has to be brought from the heating in order to guarantee the correct functioning. In next future, it will be necessary to find solution that cool device and charging infrastructure. The transformer usually works with high temperature condition, keeping high performance using the only recirculation of the external air. In some application with high powers and or with high temperature, and with the presence of the dirty air, dust and sand, it is necessary to cool the cabinet for the transformers in order to maintain a suitable working temperature. Instead, the inverter are installed in cabinet where the internal temperature has to be usually 35 degrees and they need of cooling. In fact, the inverter have a great loss of performance when the temperature is high. The Protherm Outdoor CVO air conditioner has the suitable solution for cooling of the inverter and the transformer cabinets. The wide range of the cooling capacity and power supply allowed a correct and easy installation. Driving by the increasing need to reduce the power consumption, the air conditioners are strongly oriented to have the maximum efficiency, maintain robustness, reliability, and compact dimension. The battery for energy storage works at a lower temperature than inverter device, in order of 25 degrees. The increase of the temperature produces a quickly reduction of the useful life of the battery. For cooling of the energy storage cabinet, Cosmotec offers air conditioner with direct current power supply, with cooling capacity up to 700 watt with a range CVO and cooling capacity of 1 and 2 kW with a Predator range. The air conditioner are designed to work continuously, giving maximum efficiency and reliability. The wind turbines have usually on the base a control section composed by electrical cabinet, and they need cooling. For cooling of the electrical enclosure for the wind turbine, considering the possible reduced available space. The suitable products are the Slim-In, design range for external semi-flush and flush installation configuration, and so suitable for request about reduced depth of outside enclosure, or alternative top mounting air conditioner range top. The air conditioner, mainly the slim range, offer efficiency, reliability, flexibility, and easy installation with a precise and suitable technical solution. At the end, more installer power directly on the charge column can require the need to have an airflow with external in order to dissipate the internal heat load, offering at the same time a suitable protection against the external agents. For cooling of the column that we can call it high power for the fast charging, the solution is the filter fan Krios 3, when the ambient temperature is lower than request internal temperature. Thanks to its reduced depth, they are installable on several columns. Moreover, they allow the reliability with certified protection degree and high MTBF flexibility and easy installation. All these applications want to be indication, not a must. For example, not all charging columns need of cooling, and as not all cabinet has to be cooled. But it is correct to consider that the market is increasing. The quantity and the type of installation are increasing, and so consequently we can find in the situation request of cooling for the network. Thank you for the attention. The webinar is finished, and we wait in case you have some question. We have a question about the control, if the air conditioner can be controlled remotely. Yes, Slimin is a RS485 port, serial port integrated on the rear of the air conditioner, so you can connect it with a Modbus protocol. The Predator and the ProTherm unit is possible as an option or or as an accessory. In both cases, it's possible to connect with the Modbus protocol. Can I install the air conditioner inside an nice in the cabinet? The ProTherm is possible to install in external of the cabinet. Instead, the Predator or Slimin, you can install it in flash, semi-flash, or in external configuration. About the needs, it's necessary to consider the airflow of the air conditioner, mainly the outside airflow, because it's necessary to avoid the intervention of the high pressure switch. Can I have the air conditioner made in stainless steel? Yes, it's possible, except the Predator unit. So the ProTherm and Slimin, and also the top roof mounted air conditioner is possible, and the stainless steel option is available for our product. So we wait some minutes in case there are other questions. Okay, the question is finished, and also the webinar. And thank you for the attention, and bye.